We can tie these things to conventional engineering where it makes sense. And we'll get into that a little bit too. First, I want to explain this motor a little bit so you have some of the history behind what we're dealing with, and then we'll go into some of the vibration physics. This little... Is that all right? Okay. This motor was given to one of Keely's lawyers in the late 1800s. We assume it was given to him, it was part payment or whatever, we don't know exactly. Mr. Housen. Later on, he donated this to the Franklin Institute in Philadelphia, and it sat in the Franklin Institute for 50 years. And they had a little sign on it that said it was a perpetual motion machine. Well, it was not a perpetual motion machine. They called it that because they didn't know what it was or how it worked, and they didn't have any idea about it. They just called it perpetual motion. And my friend Victor Hansen, who is in the other room, he owns this machine. He bought it from the Franklin Institute for $1,000. Took him 8 years to get the money together to pay for it. He eventually got it and took it home. And he had it since the 40s. So he's had it for another 50 years. 3 or 4 years ago, I had a chance to look at it for the first time, and if any of your engineers and you look at this thing, you say it is absolutely bizarre. There's no way this thing can work, because in conventional male-oriented physics, where we put in energy, we've got to hit it with something. This makes no sense because it doesn't operate with that philosophy. It operates with the female forces of implosion, so the thing kind of operates backwards. And when you look at it a little bit and you say, well, this thing operates backwards, and then all of a sudden your mind just gets all clouded and confused because you're not used to thinking in those terms. But after a while, it gets kind of simple. And this is brilliant. If Keely did anything, he was a brilliant machinist and a brilliant mechanic. He just had a cleverness of making things. Water would come in through this orifice. Once he got the thing primed with water in the system, he could just kind of give this thing a little crank, and it would create a vacuum, and the water would draw itself through the machine. Now, one interesting concept is the water formed a part of the mechanism. That's not normal physics. That's not normal engineering. We don't normally do that, where the water is actually part of the motion of the machine. So this thing is kind of like a holistic machine. It's not a machine operating on the water or the water operating on a machine. It's the water and the machine operating together as a whole unit. It's kind of like the human body does. So I give this thing a crank. Water will come into here above this level, this tube, this horizontal tube that goes across the front. The tube goes through this pulsating chamber. I call this a pulsating chamber. And the tubes are hollow. There's nothing inside of them. The same thing with this tube. It's just a straight tube. There are holes in the center so it has access to the internal volume of this pulsating chamber. This chamber is 1/64th of an inch in thickness. It is red brass. It's very hard, very resonant type brass, whereas this is a yellow brass. This is red brass, kind of like a naval brass. And the interesting thing is, once the water came into this and started through the system, this chamber would begin to pulsate. And because it's mostly got air in it, we would have a pulsation of a high and low pressure forming at intervals, very high frequency. So this becomes a pump. Once the water is in motion, this pulsating chamber becomes a pump with no moving parts. It's really ingenious. Just a year ago, I ran across a NASA paper where these guys, some engineer didn't even have his name on the paper, had designed a waveguide using a transducer, and he had developed a pump using a transducer there again with no moving parts. So here was a validation from NASA that this concept works. And I thought that was really good that we ran into that paper. In these two mechanisms, one on each side, these are check valves. The water would come across horizontally and start up through this check valve, and all it is a round ball sitting on a round hole. So water could come this way, but it can't go back down. Then the water would come through these pipes around here, there's two on each side, into these pistons. Now, there's two kinds of pistons. This is kind of an enigma why there's two distinct designs on these pistons. They are not the same. in this left side, your right side, we have what we consider standard piston arrangement. Underneath, we have a bar that goes underneath that pushes a piston up into this larger chamber. The water would come into the top of that cylinder, on top of that piston. And in the end, there's a valve that goes straight through here. It's a rotary valve, so it just rotates. In this case, it just rocks back and forth. So the water would come through that cylinder. When the valve got in the right place, the water would shoot through into this cylinder, pushing this crankshaft and causing it to rotate. It's real simple. However, the things that go on while it's doing all that is really neat. The pulsations would drive the water past the check valves into this cylinder down here, pushing this rod down, which lifted this weight on the far side here. So it lift this weight on the far side, thereby putting pressure on this water in this cylinder. So here we've got water under tremendous pressure because the injections of the pulsating waves pounding that water. The minute the little rocker arm rocked the valve back and forth, we've got a high velocity stream of water coming past the valve. So when you close the valve on high velocity water, what do? You get a water hammer. You get that pounding. And water hammer is when you close the faucet in your sink and the pipes bang in your basement. That's water hammer. There's infinite pressure in that. So that pressure, I did a computer model of what happens in here. And of course, computer model is based on ideal conditions, which this isn't. But I was surprised that it showed within 8 cycles of this valve opening and closing, the pressure goes to infinity. Now that's an ideal situation, which this isn't. So we got the high-speed stream of water coming through the valve system, pushing this piston up, and would cause a little bit of rotation. And on the other side, there's 2 types of water hammer, by the way. There's upstream and downstream. Water coming into a valve, you shut the valve, that water has a momentum that keeps going against the valve. And the reverberation of this shock wave going back upstream, away from the valve, creates a pocket of negative pressure, low pressure, a vacuum, which will collapse as you impose it, causing a pounding. On the downstream side, the water wants to keep going, so it creates another vacuum, which collapses and causes another shock wave. So if we time that shock wave back and forth on either side of the valve, it goes upstream up the pipe, and it comes back down. If you open the valve at the same time that reverberation of the shock wave comes back, it will add to the original. It's like a child on a swing. You push a child on a swing. If you push it at the right moment, it'll get bigger and bigger and bigger and bigger. And by the way, that is the same principle that Worrell used in his valve assemblies in the 1930s and 40s, where he caused an oscillation of electrical current. It's much like Bearden talks about today with scalar electromagnetics, where they got bifilar coils and they got this tremendous charge of current, not current, but potential that they oscillate back and forth. So we've created a potential in here, and we oscillate it back and forth, and the valve lets loose just enough to keep the mechanism going. On the other side, there is a slightly different, well, it's fundamentally different thing happening. Because this piston down here does not capture water. It is a round ball sitting in a round hole. So when the water squirts through here, it hits on top of this ball and then goes immediately all over the place. But while it does that, it creates a vaporized situation on top of that sphere, and it polarizes the water. Right above the round portion, we have a little chamber in here. It's a little square chamber, and that bothered me for 2 years, what this chamber was all about, because it's a rectangular hole going through this little chamber. That when the ball closes, it closes one end of it, and when the valve closes, the other end of it's closed. And I got to thinking about waveguides and whatnot. This thing is a